What if you could hop on a spaceship and cruise around the solar system? It would be like an interplanetary road trip. This is not possible with current technology, but scientists have recently discovered a way to zip around our own solar system using superhighways that run between planets, moons, and the sun. In the future, traveling from planet to planet might be similar to hopping in your car, merging onto the highway, and cruising to your destination. Space is so incredibly vast, it's almost unfathomable. Our own solar system is so large that it takes light, the fastest moving thing in our universe, about 8 minutes and 20 seconds to reach the Earth from the sun. It takes that same light approximately another 5.5 hours to reach the outskirts of the solar system. The problem is that humans cannot travel at the speed of light yet. So if we're going to fly around in space anytime soon, we need a means of getting from one planet to another quickly. No one wants to leave Earth behind for Jupiter and get there decades later. By the time you reached your destination, you would be too old to enjoy it. Currently, we're constrained to certain speeds by the technology we have available. And even though technology is advancing at an astonishing rate, it'll be a long time before we can quickly travel between the planets. However, the newly discovered superhighway around our solar system may make interplanetary travel more realistic in the near future. That is, if we can accurately map it and utilize the gravitational forces that allow the superhighways to exist. At the most basic level, the superhighways through space are created by the gravitational fields of planets, moons, and the sun. Ever since humans have been launching vehicles and satellites beyond Earth's immediate orbit, we've been using the gravity of other celestial bodies to increase the speed of our spacecraft. By calculating the correct trajectory, a spacecraft can literally circle an object at a specific angle and use the object's gravity to slingshot itself into a precise direction. By using these maneuvers, the spacecraft can gain a massive amount of speed every time it passes by a large body such as a planet or moon. The newly discovered superhighway uses these same gravitational fields, but takes advantage of where they meet. All of the celestial bodies in our solar system interact with one another. The sun pulls on Mars, but Mars also pulls back on the sun. Same goes for Mars and Earth, or Earth and Jupiter. All the moons and planets are pulling on one another, even if just slightly. Scientists have discovered routes through the solar system where this interaction can actually speed up objects that run through them. Most recently, this phenomenon was identified by a research team led by Natasha Todorovic of Belgrade Astronomical Observatory in Serbia. Todorovic and her team discovered a series of arches where different gravitational fields meet to allow objects moving through that section of space to travel faster than expected. The term that Todorovic's team used to describe this region of space is the celestial autobahn. You might be wondering how scientists like Todorovic even discovered this planetary superhighway in the first place. The answer is actually pretty amazing. The paths through space that make up the superhighway can't be seen with the naked eye. Scientists need to observe how objects travel through our solar system, like comets and asteroids, to identify the specific paths the superhighway follows. Todorovic and her team observed 3 sets of objects in specific regions of space to make their groundbreaking discovery. The first group is called Jupiter family comets. They have an orbit of less than 20 years and don't stray from Jupiter's gravitational pull. The second group are centaurs, which are icy chunks of rock that travel between Jupiter and Neptune. And the last group observed were trans-Neptunian objects, which travel to the farthest reaches of our solar system. The last 2 categories of space objects have orbits that can range from decades to a billion years. When Todorovic and the other researchers first examined this region of space, everything seemed normal. But then they noticed something strange. Some of the centaurs and trans-Neptunian objects should have orbits that take thousands or millions of years. They were moving much quicker than they should have been. This led Todorovic and her team to investigate further. They knew about gravitational slingshotting around planets, but the objects were continually moving faster through space, not just at specific points near planets and moons. It was like they had been put on a high-speed conveyor belt in the middle of space. Using complex mathematics and modeling, the scientists discovered that certain asteroids and comets were speeding up in this region. The objects were not just being affected by points in space where massive gravitational fields were present. Instead, they were following a network of deep space highways, running around planets and through empty space. This was the first set of discoveries that led to identifying the superhighway in this region of the solar system. Todorovic and her team collected data on millions of orbits in the solar system, trying to figure out the path that the superhighway took and what was causing the phenomenon that was increasing the speed of objects in it. It became clear that it was the gravitational interaction between celestial bodies within the solar system that was creating the superhighway. Unsurprisingly, one planet in particular was having a massive effect on the path of the superhighway: Jupiter. Scientists have been using Jupiter for decades as a means to accelerate spacecraft that are traveling into the deepest parts of our solar system. Voyager 1 and Voyager 2, the 2 furthest man-made objects from our planet Earth, both use Jupiter's massive gravity field to slingshot them to the stars. These 2 spacecraft are no longer in our solar system but are traveling through interstellar space. Without the massive gravity assist of Jupiter, the Voyager spacecrafts would have taken decades longer to reach the edge of the solar system. That being said, scientists at the time when the Voyager missions were launched had no idea that a superhighway between the planets existed. Understanding what Todorovic and others are now discovering about the pathways through our solar system will have a huge impact on the future of space exploration. At this point, you might be wondering, how much faster is the superhighway than traveling through regular space? The answer is a lot faster. Keep in mind that there are incredibly long distances between any two planets in space. Normally, objects traveling between Jupiter and Neptune take hundreds of thousands to millions of years to travel from one planet to the other. However, researchers found that objects following the path of the superhighway made this journey in a matter of decades. Decades seems like a long time for us humans, but millions of years is much longer. This means objects traveling along the superhighway were moving from 1 to 100,000 times faster than similar objects in normal space. So if a spacecraft carrying people were to hop onto one of the superhighways and add its own thrust, the time of travel between planets could be greatly reduced. These superhighways are by no means a replacement for the need to find a faster way to travel in space, but it will definitely be helpful on our journey to other planets in our solar system in the future. Also, there are other benefits to understanding the superhighway. Some are even more important than speeding up space travel, especially for those of us who are stuck here on Earth. By understanding the path the superhighway takes, astronomers and scientists can better predict the paths of comets and asteroids traveling around the inner solar system where Earth orbits. This is important if we want to protect our planet from impacts with these objects. Although space is a big place, given enough time, celestial objects tend to run into one another. Earth is just another rock floating through space, and it's only a matter of time before our planet crosses the path of another space rock. Just think about what happened to the dinosaurs the last time Earth came into contact with a rogue asteroid. By utilizing a map of superhighways, scientists can have a better understanding of where to look for incoming asteroids. No matter what is rushing toward Earth, the more time we have to plan and prepare, the better. If scientists can track the movement of asteroids and comets through the solar system's superhighway, then we can predict more accurately when one of these objects will be crossing our path and prevent it. There's a plethora of technology being developed by space agencies around the world to knock an asteroid off its collision course with Earth, but they all require a long time to implement. Understanding the superhighway can give scientists even more time to change the path of an incoming object, and the more time they have, the higher the success rate will be for preventing a life-ending impact. Another reason that scientists are studying these pathways extensively is because if humans ever plan to use them, we need to know where different highways meet or cross paths. We already know objects such as asteroids and comets travel quickly around the solar system using the superhighway. So if we're going to put spacecraft on the same paths as these chunks of rock and ice, we need to be able to avoid collisions with them. Junctions where different paths cross are predicted to be places with high concentrations of space objects. It may be at these junctions where most of the space debris enters the superhighway. So spacecraft nearing such junctions will need to proceed with caution. But if we can use the superhighway to transport spacecraft, supplies, and people around the solar system, it would change everything. It would be the freeway of the future. And like any highway, whether in space or on our planet, it needs to have some sort of rest stop. Martin Lowe, a researcher at NASA, suggests there are junctions along the superhighway that can be used as refueling stations or supply stops. These stations could sit at precise locations where their orbits could remain indefinitely, using only the gravity created by planets and the sun. No energy would be required once the station was in the correct position along the superhighway. This would occur at what are called Lagrange points. These locations in space are where one celestial body's gravity balances another. Using Lagrange points, Lowe mapped parts of the space superhighway near Earth, where the different paths meet and gravity balances out. It's at these points, platforms or space stations could be built for refueling or to provide supplies for travelers along the superhighway in the future. Once the superhighway has been charted, there are obviously some downsides, just like any set of roads. For example, the desired destination may not be directly along the route. Say you want to get to Neptune from Mars. This journey is long and will most likely cause the spacecraft to go through several junctions. Perhaps the route the superhighway carries objects through actually takes longer than if it were a high-tech engine that could launch you in a straight line across the solar system. Since there could be many different pathways, you may have to wait until the planet you're on is in the right spot in its orbit to reach the path of the superhighway you need. This is already a limitation of space travel. When planning missions to Mars from Earth, scientists need to wait for specific times of year when the two planets are at their closest points relative to their orbits. It makes no sense to launch a spacecraft to Mars when it's on the other side of the sun. The same thing would be true of the superhighway. If the junction onto the superhighway you need is on another side of the sun, you'll have to wait until your planet orbits to that location. The interplanetary superhighway is a relatively new discovery, and we have a long way to go before humans will be zipping around the solar system on family vacations. But at the very least, our understanding of the superhighway and how it moves objects quickly around the solar system will help astronomers identify objects that are on a collision course with Earth. In the near future, space agencies will likely consider using the paths of the superhighway to allow spacecraft to travel more quickly and efficiently through our solar system.